Hello, students. This is Mr. Hatfield. I hope you're enjoying your holiday. Certainly, everybody needs a little time off now and then, but we do have a semester to finish. And so while we're on holiday, I'm going to go ahead and provide you this video, which is going to review the procedure on how we convert units of pressure or units of energy. Let's get after it right now. Okay, we're going to begin with a non-metric unit, which is the atmosphere, which is approximately the pressure of the atmosphere at sea level. It equals an old-fashioned unit called millimeters of mercury, which was based upon the original barometer, which was an open pool of mercury, and atmospheric pressure pressing down on that pool would cause a thin line to rise inside a glass tube, which was measured out with increments. And so 760 millimeters of mercury roughly equals the pressure of 1 atmosphere. In addition to that, we have the modern metric unit, which is the kilopascal, symbol little k rather, and capital P little a, 101.3 kilopascals. Now, in addition to these equivalencies, we want to point out to you that 1,000 pascals, which is the same as 1,000 newtons per square meter, that equals 1 kilopascal. And so with the metric unit, we can relate the unit for force and the unit for area to the unit for pressure, because pressure is literally just force divided by area. So with these basics understanding, let's just talk about how we would convert. Let's say that we're given a total of 2.2 atmospheres. That's our given. Well, as always with this technique, we would write that as a fraction over 1 inside parentheses. Let's say we wanted to convert that to millimeters of mercury. Millimeters of mercury. Well, okay. Our conversion factor says that for every 1 atmosphere, there should be 760 millimeters of mercury, okay? Since we have atmospheres on the top of the first expression, we should write that on the bottom here, because our goal will be to cancel that atmosphere. And then we would have 760 millimeters of mercury here. Now we cancel. So in this example, everything on the bottom being 1, that means we simply have to multiply on the top. And when we get done multiplying, we're going to discover that this is 1,672 millimeters of mercury. Why is it millimeters of mercury? Because that's the unit that was not canceled. Now we can reverse this process. We can say to ourselves, well, suppose we are given a number in millimeters of mercury rather than say atmospheres or kilopascals. Okay, well, let's say that we are given a number. Let's say it's going to be 1,520 millimeters of mercury. That's our given, so we write it as a fraction over 1 inside parentheses, as we always do. Our conversion factor says that for every 760 millimeters of mercury, that there would be 101.3 kilopascals, right? Okay, so the millimeters of mercury cancel out because of the position we do. If we do the math, what do we discover? Well, we discover that this 202.6 kilopascals, and that would be a very unpleasant pressure indeed. See that we're given a number in kilopascals. Let's say it's 303.9 kilopascals, and that would be a lot of pressure, very unpleasant. We write it as a fraction over 1 inside parentheses. Let's say we want to put that into atmospheres. Well, our conversion factor says that for every 101.3 kilopascals, we would have 1 atmosphere. And so we cancel the kilopascals. In this case, notice that we have a non-1 number on the top, non-1 number on the bottom. Here we're going to divide. So you get done doing the math, and we determine that that would be 3 atmospheres of pressure. Unpleasant, but perhaps not fatal to any of us. So these are all very straightforward, one-step conversion factors that where we cancel the term. But suppose we're given a problem where there is no direct one-on-one conversion provided. Let's see what that might look like. All right, let's say that we're given 420 pascals and we want to know how many millimeters of mercury that would be. So in this case, we don't have a one-to-one conversion factor possible. So we're going to need more than two fractionals. We're going to need more than two fractional setups. So again, we write our given first as a fraction over 1 inside parentheses. Now we're going to convert the pascals into kilopascals. And so for every 1,000 pascals, we'll have 1 kilopascal. And then at the end, we're going to say for every 101.3 kilopascals, we're going to have 760 millimeters of mercury. So this is obviously a lot more complex as far as doing the actual calculation, because we have non-one numbers on top and bottom, and you're going to need to multiply them in order to before you do any division, right? Multiplication will take place before division. But let's go ahead and do our cancellation and get rid of some of the clutter. So pascals will cancel, and then the kilopascals will cancel. So this is going to become 420 times 760. And that is this number, 319,200. And then the bottom is going to become 1,000 divided by 101.3, which this is just 101,300. Okay, so if we do the math, a very small number indeed. So this reduces just to being 3.16 millimeters of mercury. Let's now look at a similar set of conversion factors for energy. Okay, so the conversion factors for energy have been given previously. We have a metric unit, which is the joule, and the 1 joule, J, is essentially 1 Newton of force times 1 meter of displacement. So that's where we derive the unit of energy from, is from the unit of force times the unit of displacement. And we have a situation where the metric unit, the joule, 4.184 joules will equal a non-metric unit called the calorie. And the calorie is a very convenient unit. It's the amount of energy necessary to raise 1 gram of water 1 degree Celsius. So while the calorie is a non-metric unit, it is intended to work very well with a temperature scale that is in the metric system, and it's based upon a very common substance, which is to say water, so it's very convenient. Now, 1 calorie is really not a lot of energy, and so the calorie that appears on the side of food, like your breakfast cereal, is not the lowercase calorie, but instead it's a larger calorie, which is sometimes just capital C, or we say 1 kilocalorie. And we write kilocal for short, and we often write just cal for short for calorie. Okay, so let's say that we're given a total of, all right, let's say that we're given 12.552 joules, and we want to know how many calories that is. Well, we write our given over 1 as a fraction inside parentheses, just like we always do. Since we have joules on the top here, we're going to put the 4.184 joules on the bottom here. And then on the top, we would have 1 calorie. Okay, so this is a situation where we have a non-one number on the top, a non-one number on the bottom. So we're going to do division. And if we do division, what do we discover? Well, we discover that this is precisely 3, and we have 3 calories. Or someone could tell us, hey, we've got 7.2 kilocalories is our given. We want to know how many calories that is. So we write it as a given over 1. It's a fraction inside parentheses. Our conversion factor says that for every 1 kilocalorie, we have 1,000 calories. So kilocalories will cancel, and our answer here is 7,200 calories. In this case, notice that we only have non-ones on the top, and so it's just multiplication. But what if we're given a complex problem where we need two conversion factors like before? Well, in that case, we will have something like this. Okay, let's say that our given is 72 kilocalories, but we want to know how many joules that would be. Well, we don't have a one-step conversion factor, so again, we're going to need to have two conversion factors back to back. As always, we write our given first as a fraction over 1 inside parentheses, 72 kilocalories. Our conversion factor to get to calories is that we have 1,000 calories for every kilocalorie. Once we've gotten here, we're home free. We'll use this. 1 calorie equals 4.184 joules. And of course, our kilocalories and our calories will cancel. This becomes 72,000 times 4.184, or 301,248 joules. So as you can see, these factors where we convert units of pressure or units of energy, they are pretty much all the same. They're pretty much all the same. And so we simply have to get in the habit of writing our given as a fraction over 1, and then identifying the common terms that we want to get rid of, which will help us figure out how to set it up. Because after all, the term, the unit that's given in the first expression, it will be at the top. And in order to cancel it, that same unit, that same expression will need to be at the bottom in the next fraction. And using that logic, you can fill up your empty parentheses with complete fractions with the right numbers attached. And then it's just a question of doing either multiplication or division or both. All right. So I hope that refresher, that reminder on how to do these kind of problems was helpful. And I look forward to working with you guys in our class meetings in just a few days. Take care.